Welcome to our deep dive, and you're into the history of visual perception. It's going to be pretty interesting. I think
Yeah.
we're going to kind of take a journey through time, you know,
Yeah.
and explore how humans have come to understand the act of seeing
Right.
from those like ancient theories about, light beams coming out of our eyes
Oh,
to
yeah.
the more modern understanding that, our brains actually construct what we see.
Absolutely.
We're going to be using excerpts from this book called Perception and Illusion, Historical Perspectives.
Okay.
And I think there's going to be some really surprising discoveries in here for you.
I'm sure there will be.
Did you know that a device called a camera obscura was key to understanding how our eyes work?
Yeah, it's interesting how something so fundamental to human experience,
Yeah. Right.
has evolved over time.
Right.
And what we take for granted today, thousands of years ago was,
Yeah.
a source of intense debate and speculation.
Yeah, it's wild to think that early thinkers like Euclid actually believed that vision.
Right. Worked by light emanating from our eyes, like beams shooting out.
Yeah.
It makes sense in a way.
Yeah.
You close your eyes, the world goes dark.
It's a logical kind of leap from observation to theory.
Right.
But Aristotle saw things a little differently.
Yeah.
He proposed instead that light enters the eye.
Okay.
And these contrasting theories, the emission and reception theories of vision,
Right.
were fundamental to how early civilizations approach the nature of vision.
So, how did we move beyond these early ideas of, light beams
Yeah.
to a more, accurate understanding of vision?
Well, I mean, throughout history, humans have had this urge to record what they see.
Yeah.
Think about cave paintings created, tens of thousands of years ago.
Right.
Those were early attempts to capture the visual world,
Okay.
a reflection of how humans were already trying to grasp and interpret the world around them.
That's a great point. I mean,
Yeah.
art has always been intertwined with our understanding of vision.
And when we get to the Renaissance, I mean, artists like Da Vinci were obsessed with making their paintings
Yeah.
as realistic as possible.
Right.
Wasn't that kind of a turning point?
Absolutely. The
Yeah.
Renaissance artists' pursuit of realism led them to explore perspective.
Yeah. Yeah.
The technique of representing 3D space on a flat surface.
Right.
This wasn't just an artistic pursuit. It had a profound impact on the scientific study of vision.
Wow.
And one of the key tools that emerged during this period
Yeah.
was the camera obscura.
Okay, so tell me more about the camera obscura
So-
and how it relates to our eyes.
Well, imagine a dark box with a tiny hole on one side.
Right.
Light passes through that hole
Yeah.
and projects an upside-down image on the opposite wall.
Ah.
And artists use this device to understand how light creates an image
Right.
and to help them achieve accurate perspective in their paintings.
Okay.
What's truly remarkable is that Leonardo da Vinci compared the eye to a camera obscura, suggesting that the eye also works by capturing and focusing light to form an image.
So the camera obscura wasn't just a tool for artists, it was a model for understanding the mechanics
Right.
of the eye itself.
Absolutely.
It seems like such a simple device,
Yeah,
but it has such a huge impact on our understanding of vision.
it did.
It's incredible how scientific progress can come from unexpected places.
It highlights the interconnectedness of different fields,
Right.
Art and science,
Yeah.
and how they can influence and inspire each other.
Totally. But even with the insights gained from the camera obscura, we still didn't have a complete understanding of how the eye actually worked.
Yeah.
It wasn't until the 17th century that scientists like Kepler and Scheiner really cracked the code.
Right.
So what exactly did Kepler and Scheiner discover that revolutionized our understanding of the eye?
They provided a much more detailed anatomical understanding of how the eye works.
Okay.
Kepler, building on earlier work, showed how light passes through the cornea and the lens of the eye and gets focused onto the retina at the back of the eye.
Okay, so it's similar to the way a camera lens focuses light onto film or a sensor to create an image.
Exactly. And then Scheiner came along and provided an even more complete picture of the eye's anatomy, confirming and refining Kepler's findings.
Wow.
This knowledge had a profound impact not just on our scientific understanding,
Yeah.
but also on our ability to address vision problems.
So this deeper understanding of the eye's structure led to practical applications, like
Right.
eyeglasses.
Absolutely. The knowledge that the eye uses a lens to focus light
Right.
meant that we can use external lenses to correct refractive errors,
Okay.
like nearsightedness and farsightedness.
Right.
Eyeglasses, which had existed for centuries,
Uh-huh.
suddenly became much more than just a way to see better.
Yeah.
They became a tangible application of this newfound knowledge of the eye's optics.
So it's not just about seeing clearly, it's about understanding why we see the way we do,
Right.
and then using that knowledge to improve our vision. That's pretty amazing.
It is.
But what about seeing with two eyes?
Yeah.
How did scientists figure out how binocular vision works?
That's another piece of the puzzle that starts falling into place around this time.
Okay.
Researchers began investigating how the two eyes work together to create a single unified image.
Right.
They discovered the concept of corresponding points on the retinas,
Uh-huh. Okay.
essentially specific points in each eye
Yeah.
that receive light from the same point in space.
Okay.
This means that even though each eye sees a slightly different image,
Right.
the brain combines them to create a single 3D perception of the world.
So it's like having two cameras taking slightly different pictures.
Yes.
And then the brain merges them to create a more complete and detailed image. That's so cool.
That's a good analogy.
But we can't talk about vision without talking about color, right? Where does color perception fit into this historical journey?
Color perception is a fascinating thread that runs throughout the history of visual science. Even in ancient times, thinkers were fascinated by color and how we perceive it.
Right.
Ptolemy, the famous astronomer and mathematician,
Mm-hmm.
experimented with color mixing using a rotating color wheel. He was one of the first to systematically study the phenomenon of color.
So he was kind of a pioneer in the field of color theory.
Absolutely. He made some important observations about how different colors can be mixed to create new colors,
Right.
laying the groundwork for later discoveries.
Okay.
But it was Isaac Newton who really revolutionized our understanding of color with his groundbreaking work
Yeah.
on the spectrum of light.
Right. Newton's famous prism experiment.
Yeah,
He showed that white light is actually a mixture of all the colors of the rainbow.
exactly.
That must have been a mind-blowing discovery at the time.
It was a paradigm shift in how we understood color.
Yeah.
Before Newton, people thought that color was a property of objects themselves. Newton showed that color is actually a property of light itself, and that objects appear colored because they reflect or absorb different wavelengths of light.
So color isn't just out there in the world, it's a product of how light interacts with objects.
Right.
And how our eyes and brains process that light.
Exactly. Newton's work was a major step forward in understanding the physics of color.
Oh, okay.
But it's important to remember that the story of color perception doesn't end there.
Right.
In fact, there were other thinkers, like Goethe.
The poet?
Yes, the very same.
Wow.
Goethe was deeply interested in the subjective experience of color,
Okay.
the way colors make us feel and the emotional responses they evoke. He argued that our perception of color is influenced not just by the physics of light,
Yeah.
but also by our individual experiences,
Right.
emotions, and cultural context.
So it's not just about wavelengths and receptors, it's about how those physical stimuli are interpreted and experienced by each individual.
Precisely, Goethe's insights remind us that perception is not just about the objective world,
Yeah.
but also about the subjective experience of that world.
Right.
It's a reminder that there's always more to the story than meets the eye.
This is also fascinating. We've gone from like light beams shooting out of our eyes to understanding how the eye focuses light, how two eyes work together,
Yeah.
and how we perceive color.
Uh-huh.
It's amazing how much progress was made in understanding vision just within these early periods.
It is.
But I'm sure there's much more to come.
Oh, absolutely. The 19th century brings a whole new wave of discoveries and innovations
Wow.
that transform the study of vision into a more rigorous experimental science.
Okay.
And with the rise of psychology and neuroscience,
Yeah.
the 20th century takes us even deeper into the mysteries of the brain
Right.
and how it creates our visual reality.
Okay.
But that's the story for another time.
All right.
Yeah.
Cool.
Awesome.
Got it.
So it's amazing to think about how our understanding of, the senses, especially vision, was kind of revolutionized in the 19th century. Yeah, it really was a pivotal time.
Right.
You see, for centuries, the traditional view, going all the way back to Aristotle,
Right.
was that humans have 5, clearly defined senses:
Yeah.
sight, smell, taste, touch, and hearing.
Right. Those 5 senses are like the classic starting point for like learning about how we perceive the world.
Exactly.
But the 19th century kind of challenged that long-held view, right?
Exactly. New discoveries, particularly those involving electrical stimulation,
Okay.
started to make scientists question, this traditional 5 senses.
Okay.
Think about Alessandro Volta, the pioneer of electricity.
Yeah.
His research found that you could apply an electrical current to different sense organs.
Okay.
and actually produce distinct sensations.
So you could stimulate the ear with electricity and create a sensation of sound, even though there was no actual sound waves?
Precisely.
That's pretty wild.
Yeah, and this kind of discovery led to a whole new way of thinking about the senses.
Yeah.
It suggested that the specific nerve that's stimulated is what determines the type of sensation we experience,
Okay.
not just the nature of the stimulus itself.
Interesting.
This became known as the doctrine of specific nerve energies.
Okay, so even if you stimulate the eye with something other than light, like with electricity, you would still perceive a visual sensation.
It's the idea.
Because it's the optic nerve that's being activated.
Right.
Okay.
This doctrine, largely credited to Johannes Mueller,
Okay.
revolutionized how scientists thought about the connection between the physical world, our sensory organs, and our brains. And it led to the exploration of senses beyond the traditional five, including what some call the sixth sense.
I remember reading about the muscle sense.
Yes.
And you know that book about the history of perception and illusion?
Exactly.
It always kind of fascinated me.
Yeah.
Is that what you're referring to?
Exactly. The muscle sense, also known as proprioception, allows you to, close your eyes and still know where your limbs are in space.
Right.
It's not sight or touch in the conventional sense.
Right.
It's about, your muscles and joints sending information to the brain about our position and movement.
It's like our brains have an internal map of our bodies.
Yeah.
That's constantly being updated.
That's a great way to put it.
Based on the feedback from our muscles and joints.
Early proponents of this idea, like Charles Bell, even suggested that there's a kind of feedback loop between the brain and the muscles.
Okay.
A constant two-way communication that allows us to move and interact with the world.
So this means that our brains aren't just passively receiving information from our senses. They're also actively sending signals back to the body to control movement and coordinate actions.
It is.
That's a pretty amazing level of complexity.
It is. And as scientists continue to explore this interconnectedness of our sensory and motor systems, they started to investigate even more mind-boggling phenomena like phantom limb sensations.
Phantom limb sensations, where someone feels sensations in a limb that's no longer there.
Right.
That has to be one of the most bizarre and intriguing things in all of perception.
It is.
What could possibly explain that?
It really highlights the power of the brain in constructing our perceptual experience.
Yeah.
Early accounts of phantom limbs, like those by Ambroise Paré, were often dismissed as mere imagination.
Right.
But as more cases were documented, it became clear that there was something more going on.
Right.
Something that challenged our understanding of how the brain and body interact.
So it wasn't just people imagining things.
Right.
There had to be some kind of neurological basis for these phantom sensations.
Think about it. For years, the brain has received sensory input from that limb.
Right.
It has built a neural representation, a kind of internal map of that limb based on that input.
So even when the limb is gone, the brain still has that neural representation, that map.
Precisely.
And it can be activated somehow.
Even though the limb is no longer physically present, the neural pathways associated with it remain.
Okay.
And these pathways can be triggered by various things, leading to sensations that feel like they're coming from the missing limb.
Wow.
It's a powerful example of how our brains are not just passively receiving information, but are actively shaping and interpreting our experiences.
This is all so mind-blowing. It seems like the 19th century was a period of, immense progress in understanding how perception works, from challenging the traditional five senses to exploring the muscle sense and even tackling mysteries like phantom limbs.
Right.
But I'm sure this was just the beginning.
Of course.
What happened in the 20th century?
Well, the 20th century saw the rise of neuroscience.
Okay.
And with it came a whole new level of understanding of the brain's role in perception.
Okay.
New technologies allowed scientists to delve deeper into the brain than ever before, revealing its intricate workings and uncovering the neural processes underlying our experiences.
So we're going from exploring the senses and sensory organs to actually mapping the brain itself.
Right.
And seeing how different areas are responsible for different aspects of perception.
Exactly.
Yeah.
Scientists started mapping the visual cortex, the part of the brain that processes visual information.
Right.
They identified specialized areas that process different aspects of vision, like motion, color, and even faces.
Wait, faces? Our brains have specific areas dedicated to recognizing faces.
That's right.
Really?
Research suggests that we might have dedicated neural pathways for processing faces.
Oh.
Which makes sense considering how important social interaction is for us humans.
Yeah.
Recognizing faces quickly and accurately is crucial for survival and social bonding.
So it's not just about our eyes detecting the features of a face.
Right.
Our brains have evolved specialized mechanisms
Yeah.
to process and interpret those features as a whole, as a face.
Right.
It's incredible.
It really highlights the complexity and sophistication of the human visual system. And this discovery opened up a whole new field of research on face perception,
Okay.
exploring how we recognize familiar faces, how we distinguish between different expressions,
Right.
and even how we perceive attractiveness.
It's amazing to think that something as seemingly simple as recognizing a face
Right.
involves such intricate neural processes.
It does.
But before we dive deeper into face perception,
Sure.
let's kind of step back for a moment
Okay.
and talk about how scientists actually studied perception in the 20th century.
Okay.
What new methods and technologies did they use?
That's a great question. The 20th century saw a shift towards more controlled experiments
Okay.
and the use of increasingly sophisticated technology.
Right.
Researchers started using tools like eye trackers to study eye movements, electroencephalography, or EEG, to measure brain activity,
Right.
and even computer simulations to model the visual process.
Well, it's like the study of perception became more scientific,
Exactly.
more data-driven, allowing for more precise measurements and a deeper understanding of the neural mechanisms involved.
Exactly.
Hmm.
These advancements
Yeah.
allowed scientists to connect the dots
Yeah.
between the physical world, the sensory organs, the brain,
Right.
and our conscious experience.
Yeah.
It's like a grand unified theory of perception started to emerge.
Right.
But of course, with every new discovery, new questions and mysteries arose.
Right. It always seems like the more we learn, the more we realize we don't know.
That's the beauty of scientific exploration. And
Yeah.
one of the most exciting areas of research in the 20th century
Yeah.
was the study of illusions.
Okay, illusions. Now, that's something I can get behind.
Right.
They're always so fascinating and fun to experience.
They are.
But how did they help scientists understand perception?
Illusions are more than just visual curiosities.
Right.
They provide valuable insights into the underlying processes that shape our perception.
Okay.
By studying how our visual system breaks down, how it can be tricked or misled, we can learn more about how it normally functions.
Yeah.
How it makes sense of the world.
So it's like those optical illusions you see in books and online, but with a scientific twist.
Exactly.
Yeah.
Researchers began systematically investigating a wide range of illusions.
Okay.
From geometric illusions that distort size and shape,
Right.
to motion illusions that make static images appear to move.
Okay.
And these studies revealed fascinating insights into how our brains interpret visual information.
I remember seeing that classic illusion with the two lines.
Yeah.
One with arrows pointing out and one with arrows pointing in.
Uh-huh.
They're actually the same length.
Right.
The one with the outward arrows always looks longer.
That's the Mueller-Lyer illusion.
Okay.
A classic example of how our brains use context and surrounding cues to interpret visual information. Our perception of the line's lengths is influenced by the direction of the arrows.
Right.
Showing that our visual system doesn't just passively record what's in front of us,
Yeah.
but actively interprets and makes inferences based on context.
Yeah. That's so weird.
It is, and as research into illusions continued,
Right.
new schools of thought emerged that challenged the traditional view of perception as a passive process.
You're talking about Gestalt psychology, right?
Exactly.
I've heard that term before, but I'm
Yeah.
not quite sure what it means.
Gestalt psychology is a school of thought that emphasizes the importance of the whole, not just the individual parts.
Okay.
Gestalt psychologists argued that our brains are wired to perceive patterns,
Okay.
group elements, and organize visual information into meaningful wholes. Their famous saying, "the whole is greater than the sum of its parts,"
Right.
reflects their core belief that perception is an active process of organization and interpretation.
So instead of just seeing a bunch of lines and colors, our brains are actively trying to make sense of those elements,
Yeah.
to group them together and see the bigger picture.
Exactly. And this idea revolutionized the fields of perception.
Wow.
It led to a deeper understanding of how we perceive things like depth,
Okay.
motion, and even complex scenes. Instead of just focusing on the individual elements, Gestalt psychology showed that our brains are constantly searching for patterns and relationships,
Right.
trying to make sense of the world as a whole.
Okay, Gestalt psychology is really fascinating. It makes me think about how much our brains are doing behind the scenes
Yes.
to create our visual experience.
It's amazing.
But what about that other school of thought you mentioned, the one that focuses on perception in the real world?
Ah, yes, that's ecological psychology, championed by James J. Gibson.
Okay.
Gibson argued that we need to study perception in natural environments,
Okay.
not just in controlled lab settings.
Great.
He emphasized the importance of the observer's movement
Mm-hmm.
and the way we actively explore the world around us.
Right.
Instead of focusing solely on the stimulus on the retina,
Okay.
he wanted to understand how perception guides our actions and interactions with our surroundings.
So it's not just about what our eyes see, it's about how we move through the world,
Right.
how we interact with objects, how we use our senses to navigate and make decisions.
Gibson argued that the environment itself provides rich information that guides our actions.
Okay.
He called these affordances.
Affordances.
Yes, the possibilities for action that are inherent in the environment.
Okay.
For example, a chair affords sitting.
Okay.
A door affords opening and closing.
Right.
And a path affords walking along.
Mm.
According to Gibson, we directly perceive these affordances,
Okay.
these possibilities for action as we move through the world.
So instead of our brains constructing a representation of the world
Right.
and then figuring out how to act based on that representation,
Right.
we're directly perceiving the possibilities for action that are present in our environment.
That's the idea.
That's a pretty radical shift in thinking.
It was a major departure from the traditional view of perception as a passive process.
Yeah.
And it led to a whole new way of thinking about how we navigate the world,
Right.
make decisions, and interact with our surroundings.
Yeah.
It highlights the dynamic and interactive nature of perception.
Yeah.
How it's not just about passively receiving information,
Right.
but about actively engaging with the world.
It's like perception is not just about seeing, it's about doing, about acting,
Exactly.
about being in the world.
And while Gestalt psychology and ecological psychology offered, different perspectives on perception,
Right.
they both emphasize the active role of the perceiver in shaping their own experience.
Okay.
They showed that perception is not just a matter of passively receiving information,
Right.
but of actively interpreting and making sense of the world around us.
Yeah.
But remember, this is just a glimpse into the vast and ever-evolving field of visual perception.
Right.
There's so much more to explore.
I'm starting to realize that the more we learn about perception,
Yeah.
the more we realize how much we don't know.
Exactly.
There's always another layer to uncover, another mystery to solve.
That's the beauty of it.
Yeah.
There's always more to discover, more mysteries to unravel. The study of perception is an ongoing journey of exploration,
Right.
a constant quest to understand one of the most fundamental aspects of human experience.
Yeah.
And with each new discovery, our understanding of ourselves and the world around us deepens.
That's pretty profound.
It is. But we'll have to continue this exploration in the next part of our deep dive.
Welcome back to our deep dive into visual perception. It's incredible to see how far we've come in understanding, how we see after exploring everything from like ancient theories to the rise of neuroscience.
Yeah, it's a testament to human curiosity and
Yeah.
that drive to unravel the mysteries of the world around us.
Right.
We've gone from thinking about light beams shooting out of our eyes
Right.
to mapping the complex neural networks in the brain
Yeah.
that process visual information.
From cave paintings to brain scans, it's a pretty remarkable journey.
It is.
And yet, even with all these advancements, there's still so much we don't know about how our brains create this like seamless experience of the visual world.
That's true. The deeper we dive,
Yeah.
the more we realize the vastness of what remains unknown.
Right.
There are still so many fundamental questions about how our brains take in all this sensory information
Right.
and create a coherent perception of reality.
Yeah. It makes you realize that, what we see isn't just a simple reflection of the world out there,
Right.
but rather, a complex construction created by our brains.
Exactly. And that brings us to some of the big questions that, keep researchers up at night.
Okay.
One of the biggest challenges is understanding how our brains integrate information from all of our different senses. We've been focusing on vision.
Right.
But remember, our brains are constantly bombarded with input from sight, sound, touch, smell, taste, and even our sense of balance and body position.
Right. It's like a constant symphony of sensory information flowing into our brains.
It is.
So how do our brains manage to like weave all these different sensory inputs into a coherent and unified perception of the world?
That's the million-dollar question. Somehow our brains manage to combine these diverse streams of information, filtering out noise, resolving discrepancies,
Right.
and creating a single integrated experience of reality.
Right.
We're not consciously aware of all the work that our brains are doing behind the scenes to create this seamless perception.
It's like our brains are conducting this grand orchestra of senses without us even realizing it. Pretty amazing when you think about it.
It is.
But there's more, right?
Hmm.
What about the role of, like, our experiences and expectations in shaping how we see the world?
That's another crucial piece of the puzzle. We know our brains aren't just passively recording the world like a camera.
Right.
They're actively interpreting, making predictions, and filling in the gaps based on what we've learned and experienced in the past.
So our past experiences, our knowledge, our beliefs, they're all influencing how we see the world in the present moment.
Exactly.
It's not just about this sensory information hitting our eyes.
Right.
It's also about what our brains are bringing to the table, so to speak.
Precisely.
Mm-hmm.
And this raises some pretty deep questions about the nature of reality.
Right.
If our perceptions are so heavily influenced by our individual experiences,
Yeah.
how much of what we see is actually out there in the objective world versus in here, a product of our own minds?
Wow, that's getting to some pretty profound philosophical territory.
It is.
It's like the age-old debate about objective versus subjective reality.
It really is a fundamental question that has intrigued thinkers for centuries.
Right.
And it highlights the complexity of perception. The
Okay.
interplay between the objective world and our subjective experience of it.
Yeah.
But there's one more big question we have to touch on.
Okay.
The question of consciousness.
Okay. Consciousness, that's a big one.
It is.
How does all this neural processing, all this sensory information being integrated and interpreted
Right.
lead to this subjective experience of awareness of seeing and experiencing the world?
That's the ultimate mystery, isn't it? How do physical processes in the brain give rise to subjective conscious experience?
Right.
It's one of the biggest challenges in all of science.
Yeah.
And it's intimately tied to the study of perception.
Right.
After all, what is consciousness if not the awareness of our perceptions,
Right.
our thoughts, our feelings?
So even though we've learned so much about how vision works,
Right.
from the mechanics of the eye to the intricate workings of the brain,
Yeah.
we're still grappling with some of the most fundamental questions about the nature of reality,
We are.
consciousness, and the human experience.
And that's what makes this field so endlessly fascinating.
Yeah.
It's a journey of discovery
Yeah.
that will likely continue for generations to come.
Right.
There will always be new questions to ask, new mysteries to unravel.
Well, on that note, I think we've reached the end of our deep dive into the history of visual perception.
It has been a journey.
It's been quite a journey, exploring the evolution of ideas, the groundbreaking discoveries, and those mind-boggling mysteries that still remain.
They do.
We've seen how our understanding of vision has transformed over the centuries, from ancient philosophers pondering the nature of light to modern neuroscientists mapping the intricate networks of the brain.
It's remarkable.
And along the way, I think we've gained a deeper appreciation for the incredible complexity and power of the human visual system.
Absolutely.
This remarkable ability to take in raw sensory information and create a rich and meaningful experience of the world around us.
It is a remarkable system.
It is. So as you go about your day, take a moment to appreciate the miracle of vision, this incredible gift that allows us to connect with the world and each other.
I agree.
And remember that what you see is not just a passive reflection of reality,
Right.
but an active creation of your own mind,
Absolutely.
shaped by your experiences, your knowledge, and your unique perspective on the world.
Well said.
And if this deep dive has piqued your curiosity, don't stop here.
No.
There's a whole universe of knowledge out there just waiting to be explored.
Keep learning.
Keep asking questions, keep seeking answers, and keep diving deeper into the mysteries of the world around us. Until next time, happy exploring.
Take care.